Ancient megastructures. Engineering feats that still mystify modern architects. Modern cities rise with the help of steel, concrete, computers, and machines capable of lifting hundreds of tons, yet thousands of years before cranes, engines, and digital blueprints. Ancient civilizations shaped stone on a scale that still challenges modern understanding. Across deserts, jungles, and mountains stand megastructures so precise, so massive, and so enduring that they raise an uncomfortable question. How did ancient builders do this without modern tools, mathematics, or technology? To answer that, we must set aside the assumption that advanced engineering requires modern machinery. Ancient societies possess something equally powerful: deep, observational knowledge, collective labor, and a sophisticated understanding of nature itself. Rethinking primitive engineering for centuries, ancient builders were dismissed as crude or lucky. Their achievements were attributed to brute force, slavery, or trial and error. But archaeology has steadily dismantled that narrative. These societies measured land, tracked stars, managed massive workforces, and engineered structures that align with celestial events down to the minute. They worked with materials that modern architects often struggled to replicate. Their tools were simple. Their results were extraordinary. The Egyptian pyramids. Precision in stone. The Great Pyramid of Giza is the most famous megastructure on Earth and perhaps the most misunderstood. Built around 2560 BCE, it consists of over 2.3 million stone blocks, each weighing between 2 and 80 tons. The pyramid's base is level 2 within 2 centimeters across its entire footprint. Its sides align almost perfectly with true north, south, east, and west more accurately than many modern buildings. This was achieved without compasses, satellites, or laser instruments. Instead, Egyptian engineers used the stars. By observing circumpolar stars, those that never set, they established true north with astonishing accuracy. They used plumb bobs, sighting rods, and water-filled trenches to level the foundation. Stone blocks were quarried with copper tools and stone hammers, then transported using sledges, pulled across sand moistened with water to reduce friction. This method, once doubted, has been confirmed by wall paintings and experimental archaeology. Contrary to popular myth, the pyramids were not built by slaves. Evidence points to a skilled, paid workforce living in organized communities, supported by a vast supply chain of food, tools, and medical care. The pyramid was not built quickly or chaotically. It was the result of decades of planning, logistics, and engineering discipline. Stone joints that defy time. One of the most overlooked features of Egyptian construction is precision stone fitting. In temples and pyramid interiors, stones fit so tightly that even a razor blade cannot slip between them. No mortaron. No adhesives. Just precision. This level of accuracy required an understanding of geometry, pressure, distribution, and stone behavior under wet knowledge gained through generations of experience rather than written formulas. The result is structures that have survived earthquakes, erosion, and 4,000 years of time. Mesoamerican megastructures. Engineering in the jungle across the Atlantic. Entirely separate civilizations were solving similar problems in radically different environments. The Maya built towering pyramids and ceremonial cities, deep within dense jungles, without metal tools, pack animals, or wheeled transport. Their primary tools were stone, wood, and human labor. Yet their cities were carefully planned, often aligned with solstices, equinoxes, and planetary movements. At Chichen Itza, the pyramid known as El Castillo creates a serpent-shaped shadow during the equinoxa, deliberate astronomical display tied to religious belief. This required precise angle calculations, solar tracking, and long-term observation of the sky. The Maya also mastered limestone construction, producing mortar from burned limestone and shaping blocks with stone tools. Their buildings were designed to manage tropical rainfall, heat, and erosion problems modern architects still struggle with in similar climates. Astronomy as an engineering tool. One of the most consistent patterns across ancient megastructures is celestial alignment. In Egypt, pyramids align with cardinal directions and star constellations. In Mesoamerica, temples track solar cycles and Venus movements. In Peru, Inca structures align with mountain peaks and solar events. Astronomy was not separate from engineering. It was foundational. Without clocks or calendars as we know them, ancient builders tracked time through the heavens. The sky served as their measuring device, calendar, and compass. These alignments were not decorative. They organized agricultural cycles, religious festivals, and political authority. Buildings were tools for timekeeping and cosmic order. The Inca, earthquake-proof architecture high in the Andes. The Inca constructed stone cities that continued to defy modern engineering logic. At Machu Picchu and Cusco, massive polygonal stones interlock without mortars. Each stone is uniquely shaped, fitting its neighbors like a three-dimensional puzzle. This technique makes Inca walls incredibly resistant to earthquakes. When the ground shakes, the stones shift slightly and then settle back into place. Spanish colonial buildings, constructed with European methods, often collapsed during earthquakes, while Inca foundations survived. The Inca achieved this without written language, iron tools, or wheeled vehicles. Their secret lay in careful stone selection, shaping using hammer stones, and constant test fitting. The process was slow, meticulous, and remarkably effective. Labor organization. The true megastructure. The most impressive achievement of ancient megastructures may not be the buildings themselves, but the societies that organized their construction. These projects required tens of thousands of workers, coordinated over decades. Food production, tool manufacturing, medical care, housing, and logistics had to function seamlessly. This required administration, planning, and leadership on a massive scale. In Egypt, labor was organized seasonally during Nile floods. In Mesoamerica, work was tied to religious obligation. In the Andes, communal lavanon as mitawas, esocielo. These were not chaotic efforts. They were highly structured systems that rival modern project management. Lost knowledge, or different knowledge. Why do these structures still mystify modern engineers? Not because the ancients possessed magical technology, but because their knowledge was embodied rather than written. Skills were passed through apprenticeship, observation, and practice. When civilizations fell, that knowledge disappeared with them. Modern engineering relies on equations and simulations. Ancient engineering relied on experience, intuition, and environmental mastery. Same results. Lessons modern architects still study today. Architects and engineers study ancient megastructures, not out of nostalgia, but necessity. How do buildings last thousands of years without maintenance? How do structures resist earthquakes without modern dampers? How do designs work with climate rather than against it? Ancient builders answered these questions long before modern science formalized them. Their buildings were not just monuments. They were systems integrated with environment, society, and cosmos. The intelligence of the ancient world, ancient megastructures, are not anomalies. They are evidence. Evidence that human ingenuity does not depend on machines. Evidence that observation can rival calculation. Evidence that civilizations long gone understood the world in ways we are only beginning to appreciate again. These structures stand not as mysteries to be dismissed, but as lessons carved in stone waiting for us to listen. And as long as they stand, they will continue to challenge our assumptions about the past and the limits of human intelligence.